Hello, my name is Xiang, and today I'm going to do the video demonstration presentation for my deep learning assignment 3 for artificial intelligence. So the dataset I chose is the show dataset. In this dataset, we have the author already classified and sort the files, the picture for me, so I no need to do the pre-processing to separate them again. So in the training folder, there are 6 types of the category, which are boots, flip-flops, loafer, sandals, sneakers, and social flow. Inside each of the folder include the image for the category shoes. Okay, so for the training will be 250 around image, and for the validation will be 50 only. So let's start with the coding part. So this is my directory. I only use the dataset and the Python kernel using Jupyter Notebook. So for the first part of the program is the import libraries. So we need the TensorFlow to build and train our deep learning model, Matplot to plot the confusion matrix, and Seaborn to calculate the accuracy and the loss. NumPy is used to handle the data processing. So for the directory dataset path, I use the locker since I have already download and unzip the file. So I have already specified the train directory, which is the training, which contain the 250 image for each category, and the validation directory, which have 50 each category of shoe image. So next will be the data image generation. So this one is augmentation, is the meaning to increase the training data to become, how to say, more random and more, like for example, we rotate around, rescale the image, like a boots image, we rescale it to a different pixel, and or rotate it to become let the model to learn different angle of the same boots diagram. So we can train it more to become more accuracy. So at here we use the rescale to rescale the image to become 0 to 1, to like normalize it, because the pixel value is 0 to 255, right? We need to normalize it to become the range 0 to 1, and rotation range is around 20 degrees, so the image might be rotating 20 degrees, and shifting to shift left, shift right, sharing and zoom, flip horizontal, and when the shifting made right, the empty space will be filled with the nearest pixel. Okay, so this is the augmentation tool, like pre-processing the dataset to become more detailed. So next is loading the image into batches. So we took the training directory and validation directory into the image. We specify the target size will become 150 times 150 pixel. So it become the fixed image size to be compute. So the batch size is 32, so it means it can run 32 images at the same time. Okay. Next is the define model architecture. So in here we can see the input is the 150 times 150 pixel with 3 means RGB, red, green, blue, 3. So this is the input image, and inside the convolution 2D is the dense of each layer. So for my case, I was using 1, 2, 3 layers dense with 32, 64, 128 filters. So the max cooling is to reduce the computational power to make it more faster and save computation power. Next will be the flatten. Flatten will turn the 2D vector into 1D to let the computer do the final output calculation. So the dense is total. We have 512 level of the layers. And we're using softmax to turn the final output value to normalize it become 0 until 1 probability. Okay. For the compilation, we're using the optimizer Adam and category cross drop P. Since we are doing the category classification task, we don't need to care about the predictive. We only use the categorical cross entropy with the accuracy matrix. So next will be training the data, And here I'm using the 10 epoch, means we run the same progress to train 10 times until you can see here each of the epoch train with accuracy initial is low accuracy and high loss, but by the time the epoch increase, you will see the accuracy increase until 0.49 means it's good lah, it become more accurate and less loss. Okay, and the validation accuracy also increase and validation loss also. Okay, next is the evaluation model lah. Evaluation model, we're using the evaluation seaborn to evaluate the accuracy and print out the accuracy average and loss and validation accuracy. And here we can see the validation accuracy is higher than normal accuracy, means the validation dataset is used give us a higher correctness for the categorization. Okay, so next is the plot training. Here we can see as the number of epochs increase, we can see the accuracy is increased by time by the number of epochs. The blue line is the train accuracy. You see at the 10 epoch, we can reach the higher at around 0.5, 50% of accuracy correct. And the validation accuracy increase but decrease at the end. Yeah. So this is the graph of the accuracy against the epoch. So next is the confusion matrix. You can see the image. Confusion matrix is used to this give us the confusion matrix. Okay, let me explain the confusion matrix. This confusion matrix is the the correctness of the categorization. Okay, means that the actual is like, for example, 0 is the boots, 0 is predicted is 0 is boots, means when the boots picture given is boots actual, and the model predict is boots also 0, means it's totally correct, fully correct. So if the actual is boots but the predict give us the sandals, means it is wrong, so you get off. There's 4 wrong categorization in the confusion matrix. Okay, let me explain about the one hot encoded. So like, for example, we're using array 1 2 3 4 5. So here 2 3 4 5. So one hot encoded means that each of the image we assign with the one hot encoded, means that if the image is flip-flop, we will assign it to become 0 1 0 0 0, means that image is a flip-flop. Okay, so this is the how one hot encoded come in used for the confusion matrix. Okay, as you can see, the total correct is like 22 2. This one maybe training data is not accurate, not enough. 8 39 is good, 31 is normal. Okay, there are many wrong too. So for the total overall accuracy we get is like 41%. So it's not quite good for the real life application, but we can improve it using the hyperparameter tuning in the future. Okay, so this is all about it. That's all from me. Thank you.